Hello everyone. I'm going to go through the AP Statistics review for the midterm. There are a couple of things that I left off the midterm that I will include in this review just to make sure that I cover everything. I also wanted to direct your attention to the Quizlet that I created with all of the vocabulary that you need for the exam. So before I go over the actual review packet, I want to show you how you can access the Quizlet on the internet. So if you go to the internet and you just type in Quizlet.com. Now I think this is automatically going to log me in. If you don't have an account created, you can create your own account, and there it's pretty simple. There's also a way to create an account. You can also download an app for your smartphone, and I think it's compatible with iPhone and iPads. So if you have either one of those devices, you can actually access the Quizlet on your handheld device, and it's really convenient because I've already made the flashcards for you. So when you log on, obviously you're not going to see anything that you see on the screen right now. So if you're trying to search for the Quizlet that I created, just type in my last name and search. And it should come up with a bunch of different Quizlets that start with my name. So the very first one that should appear should be the one that I created for your exam. And you'll notice that I've added some vocabulary terms, and I'll continue to add these vocabulary terms. As I was reading through the midterm, I realized that there were a couple things that I left off the review packet. So this is just an example of all of the different vocabulary terms that I created. You can also create your own Quizlet, and I actually did this on my iPhone because I used the microphone on my iPhone, and I actually just spoke into my phone and it typed everything for me, which made it go real fast. So depending on your learning style, if it's easier for you to actually write out all the definitions, then certainly that would be the way to go. If it's easier for you just to use the flashcards that I've created, and notice if you go to the flashcard icon or the flashcard menu, it'll just give you a flashcard. So voluntary response sample, you can think about what that means. When you click to flip it, it'll give you the definitions. You can also create little tests for yourself. And so one of the options that I gave you on the exam review packet, if you didn't want to write out all of the vocabulary terms, you could either create your own Quizlet or use mine. So one of the things that you could do, for example, and notice here on the right, there's all sorts of question types. Like, for example, if you just wanted to do multiple choice and true false, if you wanted to start with the term, and then like if you wanted to quiz yourself on all 35 terms that I have currently, and like I said, I'm going to add to that, you can just reconfigure your test. And so this is a multiple choice true false little Quizlet. So for example, a simple random sample, that's a design that ensures that every individual in the population and every possible combination of individuals have an equal chance of being selected for the sample. It's the ideal sample design, but it's often not possible when we can't identify the entire population. So an alternative to copying down all of the definitions would be to take the Quizlet, and then when you're done, I'm obviously not really taking it, but when you're done, if you go to check your answers, it'll give you a score. And if you just take a screenshot of this page and submit it with your exam review packet, or if you want to forward it to me via email, I will give you credit for those questions that require you to do definitions. And the other alternative would be to create your own and then just send me the link of your Quizlet. But this, I think, will be very helpful. Oh, we're having a fire drill today. This will be very helpful with your review. So getting back to the actual midterm review, you'll notice that we have a number of formulas. I will provide these formulas. These are the formulas that are given to you on the AP exam. I think there's several pages of formulas for the AP exam, but we haven't gotten to a lot of the formulas yet. So in terms of descriptive statistics, you do need to recognize what all of these statistical symbols represent. So remember, X bar in this case is your mean. And then when you see that big that's the sigma, that's a capital sigma, the Greek letter, that is simply your summation notation. Well, you guys know how to find the mean. You basically add up all your x's, and I'm going to call them outcomes, and you divide by n, which is the total number of outcomes. So a lot of these formulas, you already know what they mean, but the Greek symbols and the subscripts and the superscripts can get a little confusing. If you remember with standard deviation, when we originally learned standard deviation, before we did it with a probability, we basically took the sum of each of the observations or outcomes minus their mean, and we squared them. And then instead of dividing by the total number, we divided by n minus 1. And that's because that has to do with the degrees of freedom and how many of the values in a data set are actually independent or dependent. So we divide by n minus 1, and then this will give us the variance. If we take the square root of that, we get the standard deviation. Some of these other formulas we didn't really use too much because your calculator does a lot of that for you. This formula here is your slope formula. And remember, slope is equal to the correlation coefficient times the standard deviation in y over the standard deviation in x. And then once you know that, you can plug it into the your linear equation. So basically, if BOO, or subscript O, is our y-intercept, you can use the mean of both x and y. So this is the mean of y minus the slope, which you just found, times the mean of x. And that'll give you your linear regression equation. Some other formulas that we've used are the probability formulas. I'm going to continue to leave the probability rules up at the top of the board in my classroom. But the ones that are given to you, this is our union. This is A or B. And remember, the general formula requires that you add A plus B, or the probability of A plus the probability of B, and subtract the probability of A and B. Now, the probability of A and B is dependent on whether or not the outcomes are disjoint, independent, or neither. And so what you'll need to remember, and this is not going to be given to you, but you're going to need to remember that this quantity, if disjoint, this quantity is equal to 0. And if they are independent, then this quantity is equal to the probability of A times the probability of B. I notice that some of you guys are still getting a little confused about the probability rules. You are not given the general multiplication rule, and that is because you're given the conditional probability rule. And the conditional probability rule basically says the probability of A given B is the probability of A. Now notice this downward U is the intersection option. That's an and. It's the probability of A and B divided by the probability of B. And if you solve this for the probability of A and B, it's the same formula. I would just multiply both sides by the probability of B. And so that's why they didn't write it twice. The only other two formulas that you'll need for this are the mean and the standard or the variance, of random variables. And so remember, again, with the mean of x, you're just taking the sum. So remember, the sigma is sum of all of your outcomes times their probabilities. And to find the variance, we take the outcomes minus the mean, we square them, multiply by the probability, and take the sum. And that gives us our variance. If we want to find the standard deviation, we take the square root of that. All of the other formulas that are listed on this page get into what we're going to do second semester. So I'm not really going to go into more details about that because you don't really need them. But anyway, you will have this formula sheet for your midterm. Getting into some of the questions on the midterm review. So the first question says there's two basic methods for collecting data, observational studies and experiments. What's the primary difference between the two methods? So some textbooks actually say that there's three methods for collecting data. They say observational studies, experiments. I'm going to abbreviate. But then they also list surveys as a way to collect data. Our textbook often just includes surveys actually our textbook may actually list them separately, but a survey is considered a type of observational study, in my opinion. So the way that I look at it, and I think the way a lot of textbooks look at it, is you either have an observational study where you're just gathering information that already exists, or you're doing an experiment. And the critical difference is that an experiment involves a treatment. And a treatment is where you are actually imposing something, whether it's a drug or an activity. I spelled treatment wrong. Okay. Anyway, involves a treatment where you're imposing something and measuring the change that you see. So I know when we first, at the beginning of the year, when we first started talking about the difference between an observational study and a treatment, we were saying that, with an observational study, the researcher doesn't really interfere with the subjects. But I think that caused a little confusion. A researcher can certainly go up to somebody and ask their opinion. That's considered an observational study. It's a survey. A researcher, if they're interested in looking, for example, at glucose levels of a group of people, taking a blood test is still, even though they're interfering, they're not really imposing a treatment. They're not looking to see if anything changes when they take the blood. They're simply trying to measure the glucose level of the blood. So that would still be considered an observational study, even though the researcher is kind of getting involved with the subjects. As long as they're not doing anything to provoke a change, it's not considered a treatment. So that's the significant difference there. In number 2, it says, what's the difference between a census and a sample? Remember, the census involves everyone. And a sample basically just involves a subset of the population. And when we're examining an entire population, there's usually something that we're interested in, some piece of information that we want to know about, and that's called the parameter. And so the parameter is whatever that value is of interest to us that we collect about a population. When we gather the same information on a sample, instead of calling it a parameter, we call it a statistic. And the goal is usually to gather a sample and then calculate the statistic in the hopes to estimate the population parameter. And because we can't always do a census every time we want information about something. So what we do is we gather a sample. Hopefully it's a good sample, it's a representative sample. So we'll talk about like the different types of sampling, the different types of bias that we have to be careful of. So as long as you have a large sample, it was taken using proper techniques, then hopefully the statistic that we obtain is a good estimate of the population parameter. And there's really no way to ever know if we have a good statistic. And that's actually the emphasis of second semester. It deals with inference, basically taking what we get from our sample and figuring out how reliable that value is and how much we can depend on that value as an estimate for the population parameter. So those are two distinct differences there. In the next two sections, again, I'm not going to go through the definition of each of these terms because you can take the Quizlet. All the definitions are there. But I do want to kind of talk about bias in particular because there was some confusion with bias. So selection bias, that's when choice is involved in the selection of the sample. As soon as choice is involved, there's going to be bias. And that means that whether it's the subjects who choose to be part of the sample, and that would be like a voluntary response sample, or whether it's the researcher that chooses the subjects or chooses the people they're going to interview. And that would be more like a convenience sample. Both of those sampling designs involve selection bias when there is choice involved in the selection of the sample. Your selection should always be random to eliminate or at least reduce the bias due to the selection process. Response bias is basically any time someone's response is altered or influenced, whether it's by the interviewer, if you're doing a face-to-face interviewer and someone's uncomfortable with the questions that they're being asked, so they adjust their response, or maybe you're doing a poll of a group of people and people feel influenced when everybody else is raising their hands to also raise their hands. It could be that they don't understand the question. It could be that the question is worded poorly, and this could be a face-to-face interview or an anonymous survey that they're completing. But response bias is basically whenever someone's response is influenced for whatever reason. That should be a J, sorry. I don't know if that's the best way to describe it, but it's basically when someone's response isn't authentic. In letter C, undercoverage. Undercoverage is basically when there are groups of individuals in the population that are missed or overlooked in the selection process. So an example would be, for example, if I am using the phone book to locate people for my sample. Well, not everybody has a phone, not everybody is listed in the phone book, so if I'm only using the phone book to obtain my sample, I've got a lot of undercoverage of the people that aren't in the phone book. Even the census deals with issues of undercoverage because they look at households, and so for those that are homeless or don't live in a stable household, it's difficult for their information to be captured in the census, and so there's often undercoverage. Non-response is a little bit different. Non-response is when someone has been selected to be part of a sample, but they don't respond, they refuse to comply. So for example, if I'm doing a survey and I send the survey out to 100 people, those 100 people have been selected to be part of my sample. If I don't get that survey back from 30 people, then that's non-response. And we do estimate that I think it's like 28 to 30% of people don't respond to surveys, so there usually is a high degree of non-response with any kind of sampling design that we do. Wording effect, that's pretty much exactly what it says. It's basically when the wording of a question influences somebody's response. And so this is what we did our project on. It could be that the wording is poor and ambiguous. It could be that there's a leading statement in the question that kind of influences the way someone responds. But it's basically when the wording of a question influences the response. Okay. Sampling variability. Remember that if I take a sample of students, for example, and I calculate their average SAT score, I'm going to get an average. But if I take a different group of students and calculate their SAT scores and take the average, it's going to be slightly different. And we expect there to be sampling variability between every sample. We always anticipate. It's called natural variability. It always exists. We count on it, in fact. Variability. Okay, so it always exists. It can't really be eliminated unless you're able to do a census, which just isn't even conceivable in most cases. So natural variability always exists. It can't be eliminated, but it can be reduced by increasing the sample. And we'll talk a lot about this next semester. Okay. If there is bias in the sampling design, it's not the same thing as sampling variability, but I know there was a little bit of confusion with like how to reduce bias. Increasing a sample size will not reduce bias. If I am taking a convenient sample of 10 people, increasing my sample to 100 of my friends doesn't make it any less biased. So increasing the sample size reduces the sampling variability, not bias. The only way to reduce bias would be to consider using random techniques for selecting your sample, making sure that your wording is proper, doing an anonymous survey. So there are other ways of reducing bias, but bias and sampling variability are not the same thing. Okay, there were several terms that I left off this worksheet that pertain to experiments that are on the midterm, so I just want to make sure that we hit them. The principles of a well-designed experiment, remember, are randomization. And with randomization, it's a little bit different than, I can't talk and type and write at the same time, randomization. Okay, so randomization in the experimental design is different than it was with sampling. When we're sampling, we're randomly selecting people from the population to be included in our sample. With an experiment, we have volunteers. It is not considered voluntary response when we have people volunteering for an experiment. The way we introduce randomization in an experiment is we take those volunteers and we randomly assign them to the groups. So our goal with randomization is to make our groups as evenly matched as possible. And if we do that with randomization, our hope is that the groups are similar. There is another method, though, to make sure our groups are similar, and that is using matching. Matching is basically, there's two ways you can match. You can either take your subjects and just make sure that every person in one group matches characteristics to other people in another group. An idealized way of doing that would be like if you had 50 pairs of identical twins, taking half the twins and putting them in one group and then the other half of the twins and putting them in the other. That would be a matching design. It is not random. Please don't confuse the two. Random is exactly what it means. It means everybody gets a number and then you randomly pick the number and assign them to a group. So randomization is very important. Another aspect would be control. We must control the lurking variables. If I have a group of people and I say, hey, I want to see if this exercise program causes you to lose weight, and I give them a program and they lose weight, without having some sort of control of all of the other factors, for example, like what are they eating? Are they changing their diet? Are there men and women grouped together? Without controlling all of those other variables, I can't really conclude that it was this program or whatever, this weight loss program that actually caused the weight loss. So we want to make sure that we have a control group. So you might have one group that is taking the weight loss program, and then you have another group of people that's not changing their diet at all, and then just see how they lose weight or if they lose weight at the end of the study. So you do need to make sure you have control of lurking variables. And finally, replication. And replication also has several meanings. So replication basically means that the results that we see, if we were to repeat this experiment on different subjects, we would still see the same results. So for example, if I am doing some weight loss study and I've done a controlled experiment and I've found that there is a difference, for example, this weight loss supplement actually does cause weight loss. If I were to perform this experiment again, I'd see similar results. So it's not like that just in this one particular example, the weight loss is happening from the supplement. It would happen over and over again if I were to replicate the experiment. Another way that we can interpret replication has to do with using more than one subject in an experiment. There is such thing as a single subject design. A lot of times we use that in psychology experiments where it's more like a study, an observational study or an experiment on treatment. But very often in order to be able to generalize the results of an experiment, we need to know that it works on several subjects. So we need to make sure that we have several subjects in our experimental design to show that it's replicated among several people. So those are the three principles of experimental design. If I ask you if I give you a scenario and ask you how to design an experiment, you want to make sure that you have a statement about each of those terms. Some other terms that relate to experiments, we've already said matching. Blocking is another way. So blocking isn't the same as matching. Blocking occurs if you suspect that different groups are going to have a different reaction. and split them up and run parallel experiments. So for example, with the weight loss example that I was already talking about, if I suspect that men and women are going to have a different reaction, or for example, men often lose weight faster than women. So if I group the men and women together, that difference may be hidden in my results. So what I would do is split the men and the women into two different groups, and then randomly assign the men to two groups, a control and a treatment, and then randomly assign the women to two groups, a control and a treatment. So I'm running parallel experiments. And so that can help me also eliminate a lurking variable. Again, if you're using a block design, it's not a completely randomized design. So just understand, if it's completely randomized, then I'm essentially taking a group of individuals, assigning them a number, and anything is possible. They can go in any of the groups. If I block first, then it would involve both blocking and randomization once I've done the blocking. So just make sure you understand that distinction. Other things, placebo, that was another word that we used. Placebo is basically one way to control the placebo effect, and it's often when you give subjects a fake treatment so that they don't know the difference. So because a lot of people, when they know they're being studied, respond a little differently. So by giving them a placebo, it kind of levels that response in all the different groups. Double blind. That's another word that is important for the exam. Double blind essentially means that neither the subject nor the researcher has any idea which subjects are in which groups. And so it often does involve a placebo, so that nobody knows whether or not they're in the treatment group. So it means that the subjects don't know which group they're in, and the researchers also don't know which group they're in. And that also is another way to reduce bias and the lurking variables. Parts of an experiment that we also have to talk about were things like, let's see, factors and levels. So in an example where I might have several different things going on. Let's say I'm trying to grow vegetables, and I'm looking at how often I should water them, and also like what kind of plant food I should use. So the factors in that case would be the amount of water and the amount of plant food. The different levels would be like whether or not I give them, water them daily, water them twice a day, or don't water them at all. And then with respect to the food, like, feeding them twice a day, feeding them once a day, or not giving them the food at all. And so a lot of times when we're talking about the factors and levels, it helps to create a little chart where you list everything. And so when we're looking at a combination, we don't necessarily need to have a control group where there's a group that doesn't receive anything. We're usually looking to see which combination maximizes the results. Oops, that. So sorry, I apologize that these were not on your original worksheet. I will include all of these terms on the Quizlet, though, so that you have all the definitions. I think that's it. And remember, a treatment group, that's the group that generally gets, that's basically your combination of factors and levels. In number 7, the difference between correlation and causation. Correlation is what you can determine from an observational study. It basically means that one variable seems to be related to another. Unless you have performed an experiment where you've controlled lurking variables, you've used randomization to control any kind of bias or response, we can't determine causation. So causation can only be determined from a randomized, controlled, and therefore well-designed experiment. That is the only way we can determine causation. So correlation doesn't mean that we can't conclude anything, because we can see an association between two variables. As one thing increases, so does another. As one thing decreases, the other thing increases. So we may see that relationship, but we can't conclude that it's the explanatory variable that is actually causing the response. So those are two other words, and I can't remember if I've listed them anywhere. But the explanatory variable is usually your independent variable x, and then your response variable is what you're measuring. All right. Describing data. Again, these are vocabulary terms. I'm not going to write them down. I'll include them in the Quizlet. A categorical variable is a variable that takes on values that can be categorized. Oftentimes they're just words or characteristics. They can be numerical, but it wouldn't make sense to take an average. So for example, zip code or area code, those are numbers, but they really are just providing a category. It kind of lets you know where people live. So something like that would be a categorical variable. It wouldn't make sense to take an average zip code. A quantitative variable is always a numeric. I will write that. Always numeric. And it makes sense to perform operations like averages and standard deviations. Okay, and an ordinal variable, it could be a number, it could be a word. It's usually some sort of variable whose values can be placed in some sort of an order. So like if you think about surveys that you've done where there's some sort of a scale where you have, strongly disagree, and then strongly agree at the other end. Okay, it's some sort of a scale. That would be an ordinal variable. It can also be numeric. So for example, you could say, on a scale to 1 to 10, how happy are you today? And that would be another ordinal variable. So it could take on values that are numbers. Okay, in number 9, this has to do with all the different types of displays. It's important not only that you can look at a display and interpret the information, but that you can create these displays. So if I give you, for categorical variables, we often use frequency tables or 2- or 3-way tables. You guys learned about bar graphs and pie charts in algebra, so you should be able to interpret those. With a quantitative variable, if we're dealing with one variable, then we're usually dealing with the frequency and how often the value occurs. And we can look at that through a line plot, a histogram, a stem and leaf plot, a box and whisker plot. And let me just show you this next screen. And these are the posters that I have next to my board in my room. So a line plot, you can see the frequency of the values. A stem plot, the nice thing about this is it actually retains the actual data value. So you actually can see the exact data set from a stem and leaf plot. That's unlike all of the other plots. The stem and leaf plot is the only one that kind of preserves the actual data. Box plots, this is something that you can do on your calculator. In fact, you will have to do this, so make sure that you know how to construct a box plot using your calculator. Histograms, remember that if a value falls on the edge of an interval, the value gets counted into the interval on the right. And scatter plots, that gets us into the 2-variable data. So when you have 2 variables that are related to one another, we often use a scatter plot to show that relationship. When I ask you to describe your data sets, remember if it's a quantitative variable, you should be talking about the shape, the center, and the spread. And so with shape, we're talking about either symmetric or skewed. With center, we're usually talking about mean or median. There's also the mode, but we don't really use it that often. And then with center, we're usually talking about the standard deviation or the interquartile range. There's also the range, but it's not as helpful in terms of describing the spread of data. So we usually stick to the standard deviation and the interquartile range. When you're dealing with 2-variable data, you always want to describe the strength of the association, the direction of the association, and the form. And so by strength, we're talking about strong, moderate, or week. Direction, we're talking about either positive or negative. If there's no association, you would just say there's no association. Well, I guess I should write it as association. And then form, we're looking at either it's linear or it's not. And so anytime you are asked to describe a distribution, you want to make sure that you are describing each of these terms in the context of the problem. Please do not just put bullets and say, oh, the association is strong, positive, and linear. That does not really tell me what's going on between the two variables. So make sure that you always write the association in the language of the problem using the context of the problem. Okay. In number 10, it says, suppose a baseball player has a 500 batting average and has 8 at-bats during a typical game. A simulation using a coin yields the following results after 20 trials. So basically, what I didn't actually use a coin. I used my calculator. I generated the numbers 0 and 1, where I let 0 represent a miss and 1 represent a hit. I generated 8 numbers at a time to represent each of the 8 bats, and then I counted how often I saw a 1. And so I did that 20 times. So what this table represents is that out of the 20 times that I did this, there were two of those trials where the player only made 2 hits. There were 6 times that he made 3 hits, 8 times that he made 4, and so forth. So this is just a frequency table that was developed from a simulation. So if I want to predict the average number of hits per game, this is very similar to when we found the expected value from a probability distribution. The difference between the two tables is that I haven't done the division yet. So this is the frequency, not the relative frequency. Relative frequency corresponds to the probability. So if I did 20 trials, if I wanted to find the relative frequency, I would take 2 out of 20, 6 out of 20, 8 out of 20. 2 out of 20, and so forth. And so if you wanted to find the relative frequency of all of these values, then you would simply find the expected value the same way you did with random variables. The other alternative would be to find, so for finding the mean, the other alternative would be to still do 0 times 0 plus 1 times 0 plus 2 times 2 plus 3 times 6, 4 times 8. You get the idea, right? And then we'd have 8 times 0. Since I did 20 trials, then I would have to divide the whole thing by 20. And so the only difference between what we did with random variables and what I just did is that instead of dividing by 20 over and over and over and over again, I'm just dividing by 20 once. You will get the same result either way you do it, and it should be an average of 3.85 hits out of 8 at-bats, 8 at-bats on average. Okay. In the next problem, this is an example of a two-way table. So if you remember, we've looked at two-way tables twice. We've looked at them and found proportions, and then later on when we started getting into our probability unit, we learned that determining the proportion is the same as finding the probability of a randomly selected person from the given distribution. So in number 11, it talks about the marginal and conditional distributions or proportions from the two-way table. Remember, the marginal distribution is just your totals. All of the values will be in the margins of the table. The conditional proportions are basically when you restrict. Instead of talking about everybody in the group, you're restricting on one variable and then finding the proportion from there. So in letter A, it says, what proportion of students smoke? So again, please use proper notation. So if I'm finding proportion, it's the same notation for probability. I take the probability or the proportion that the students smoke. Now I'm talking about everyone. I have not restricted it at all. I'm looking at of all the students. So what proportion of all students smoke? And what will be helpful is if you, actually I should have done this first, if you find the marginal distribution first. So if you add up all these totals, I get, this is 1780, 2239, 1356, and then our totals here are 1004, 4371, and then the total in the table is 5,375. I think I added everything right. So if I want to find the probability or the proportion of students who smoke, I'm looking out of everybody. And if I look, there were a total of 1,004 students who smoke out of the entire group of 5,375. And that, I think, reduces to 0.1868. What proportion of all students have one parent who smokes? Again, I'm not restricting anything. I'm looking at everyone who is surveyed. So now I'm just looking at the proportion of one parent smoking. And so now I'm looking at this number. There were 2,239 students that have one parent who smokes out of, again, the whole group. And this should be 0.0445. And then in letter C, of the households where one parent smokes, this is now a condition. I'm not looking at everybody. I'm only looking at a certain part of the, a certain portion of my table. So I'm only looking at, let me do this in a different color, the group with one parent who smokes. I'm not going to divide out of everybody. That's the only group of people I'm looking at. And I want to know, out of that group, what proportion have children who smoke? So when I write my notation, I'm trying to find the proportion of the students smoking given one parent smokes. And so I'm going to look for the probability of both, or the proportion of both, where the student smokes and one parent smokes, and that's the 416. And I'm not doing it out of the total group, I'm only doing it out of the total group, or the total of the one parent smoking households. So that would be 2,239. And that is 0.1858. And then in letter D, of the students who smoke. So now I'm restricting it again. Of the students who smoke, I'm looking at the proportion that come from households with one parent who smokes. So I'm looking for the proportion of one parent given the student smokes. And so in this case, I'm not looking at everybody. I'm only looking at this group, the group of students who smoke. And the ones where there is one parent who smokes is, again, 416. But now my total is 1,004. And that proportion is 0.4143. Okay. In number 12, this has to do with describing distributions in one variable. So when we're describing the shape, the center, and the spread, you do need to remember that the shape of the distribution will determine which measure of center you should use and which measure of spread. So if it's a skewed distribution, remember it's going to screw up the mean. The mean is going to be influenced by very high values and very low values. So if there's an outlier, that's going to mess up the mean. So when the data is skewed, you always want to use the median as your measure of center. And the measure of spread that goes along with the median is the interquartile range, not the range. Make sure you subtract your quartiles. You're looking for the spread around the center, and that is your interquartile range. When it comes to symmetric distributions, it doesn't necessarily have to be a normal distribution or a bell-shaped distribution. It can be uniform. The center is going to be the mean. And the measure of spread that we use around the mean is the standard deviation. All of those values, if you type your data set into a list, you can just use one variable statistics and it'll give you everything except for the interquartile range. So you do have to remember that the interquartile range is just Q3 minus Q1. In number 13, you're describing the shape of each distribution and then the relationship between the mean and the median. Be very careful when you see something that is bell-shaped, like letter A. Be very careful about calling it normal. I would simply just say it's symmetric. If you want to call it bell-shaped, that's fine. But to say that it's normal means that you've somehow assessed the normality of the graph and assessed the normality of the data using the empirical rule or using the normal, I don't know if you remember at the beginning of the year when we actually used the graph, the normal probability distribution. So be very careful about calling a bell-shaped graph normal. A normal graph or a normal distribution has certain conditions that have to be met. So it's safer to say something is bell-shaped and symmetric as opposed to calling it normal. Well, if you have a symmetric distribution, then your mean and your median are going to be very similar. They're not necessarily going to be equal, but they should be close because the median is also in the middle. With the distribution in part B, this is a skewed distribution, and we follow the tail. It is skewed right. The mean is also going to follow the tail. So in this case, the mean is going to increase and be greater than the median. And then in letter C, this is considered skewed left. And again, the mean is going to be low because of that. The tail is being stretched to the left, so the mean is going to be less than the median. Okay, I'm going to go ahead and wrap up this as portion 1 of your midterm review. I will do another video with the rest of the examples, and I will also post that to Blackboard.